Hello, welcome back to another week. So uh, in this section, for phi, we look at the Gram-Schmidt process. So this process is generating the uh, uh, orthogonal matrix, orthonormal basis. You can see here in the previous sections, in order to see whether the basis is orthogonal or orthonormal, we need to check a few conditions, right? That's what I mentioned up here, right? So uh, in this section 5, we can generate orthonormal basics without knowing the whole thing gonna be orthonormal basics or not. So this is what we call Gram-Schmidt process. All right, so the instruction is, here's a few homework questions you can play around with. And the instruction is very simple. So we need to have a basics for the inner product space. It doesn't have to be orthonormal or consist of a unit vectors. Could be any vectors. And then we can use this to make it become an orthogonal basics. Okay, so we're gonna convert the given basics into an orthogonal basics. And then we can normalize each vectors in the orthogonal basics to form an orthonormal basics. Okay, so this one probably the best things gonna happen, right? So it's very easy. So we need to have a base, which is call that B1. B can be V1, Vn, Vn. Is the basic for inner product space V. And then B prime will contain W1, W2, Wn, where we can find Wi based on the previous vectors in the vector B. And B prime will be an orthogonal basics for V. So to start, the first one is always given, which is W1 is always equal to V1. Now W2 will equal to V2 minus the inner product space between V2 and W1, and then inner product space between V1, W1 and W1. So technically, and then time W1. So this is a recursive definitions. We can think of that. Now W3 is equal to V3 minus the inner product space between V3 W1 and W1 W1 times W1, and then minus the inner product space between V3 and W2 divided by inner product between W2 and W2 times W2. So this one here, we go from 3 to 1 until we finish the whole thing. And once you have orthogonal basics, you can base on that to find orthonormal basics by finding the unit vectors of your B prime. So B prime will be the orthogonal basics, and B double prime will be an orthonormal basics. Okay, so very straightforward on that. All right, so let's take a look at the example here. So now we have a basics B have two items, which is 1101. So W1, so in this case, you can see that V1 is 1, 1, and then V2 is 0, 1. All right, by default, W1 will always equal to V1. So equal to 1, 1. All right. So now we only have to find W2 because we're in R2, so we only need W1 and W2. So W2 is equal to V2 minus the inner product space between V2 and then W1 divided by the inner product space between W1 and W1, and multiply with W1. All right. So here we go. So V2 will be 0, 1 minus the inner product space between 0, 1 and 1, 1, because W1 is the same thing as V1. and divided by the inner product space between 1, 1, and then 1, 1. And time with 1, 1. Okay. All right. So, and then just simplify and you should be okay. So this becomes 0, 1 minus 0 times 1 plus 1 times 1 divided by 1 times 1 plus 1 times 1. All right. And then time with 1, 1. Okay, and just do like that. So we get 0, 1 minus, so 0 times 1 is 0. So we have 1 over 2 of 1, 1. So we get 0, 1 minus 1/2 and 1/2. So we get negative 1/2 and then 1/2. So that W2. There you go. So that will be my B prime. B prime will contain W1 and W2, which will be 1, 1, and then negative 1/2, 1/2. So that's my B prime. So this will be the orthogonal base. All right, orthogonal basics. All right, and now when you do U1, which is the W1 over magnitude of W1, this is 1, 1 divided by radical 2, we get 1 rad 2 and then 1 rad 2. And then U2 will be W2 over magnitude of W2, which is negative 1/2, 1/2 divided by square root of 1/4 plus 1/4. So this is negative 1/2, 1/2 divided by 2/4, which is 1/2, radical 1/2. So there you go. So you add negative 1 over 2 rad 2, 1 over 2 rad 2. So B double prime equal to U1, U2, which equal to 1 rad 2, 1 rad 2, and then negative 1, 2 rad 2, and then 1, 2 rad 2. So this will orthonormal, right? This is orthonormal basics. Okay, so that's the Gram-Schmidt process. Right. Okay, so the next example will be very much similar on this. But now we have 3 of those, and we're in P2, so we look for 3 of those. So W1 equal to V1, which equal to x squared plus 2x minus 2. And then W2 equal to V2 minus V2 W1 divided by W1 times W1. So this equal to x squared plus 5x plus 1 minus the inner product between x squared plus 5x plus 1, comma with x squared plus 2x minus 2 divided by the inner product space between x squared plus 5x plus 1, x squared plus 2x minus 2, and then x squared plus 2x minus 2. And then time with x squared plus 2x minus 2. All right. So x squared plus 5x plus 1 minus width. Yeah, so by the definition, this is 1 times 1 plus 5 times 2 plus 1 times negative 2 divided by 1 times 1 plus 2 times 2 plus negative 2 times negative 2, right? The inner product between the P will be the dot product between their components. So that's how we divide it. So x squared plus 2x minus 2 here. So you get x squared plus 5x plus 1 minus width. So that's 1 plus 10 is 11. 11 minus 2, which is 9. So 9 over 2 is 4. So that's 4, 4, and 8. And it will be 9. And x squared plus 2x minus 2. So we get x squared plus 5x plus 1 minus x squared minus 2x plus 2. So W2 will be 3x plus 3. Okay, so that's how we get W2. We already got W1. And now we need to get one more, which is W3. So W3 equal to V3 minus V3 W1 over V3, I mean W1 times W1 minus V3 W2 over W2 times W2, right? That's exactly how the formula set up there, right? So when you do W3 equal to V3 minus the inner product between V3 and W1, and W1 times W1 and minus V3 W2 W2 times W2, right? Directly from the formulas of each base. And from there, you can go ahead and find V3. So V3 will be the last thing, which is 3x squared plus 6. So I get 3x squared plus 6 minus 3x squared plus 6, comma, with x squared plus 2x minus 2, x squared plus 2x minus 2, divided by x squared plus 2x minus 2, comma, x squared plus 2x minus 2, and time with x squared plus 2x minus 2. And then minus with 3x squared plus 6 in a product with 3x plus 3. Okay. And down here, 3x plus 3, and then 3x plus 3, time with 3x plus 3. And then you simplify and you get your answer. So we get 3x squared plus 6 minus with 3 times 1 plus 0 times 2 plus 6 times negative 2 divided by 1 times 1 plus 2 times 2 minus plus with minus 2 times minus 2 and x squared plus 2x minus 2 and then minus with 3 times 0 plus 3 times 0 plus 6 times 3 divided by 3 times 3 plus 3 times 3 times with 3x plus 3. So here we go. So we get 3x squared plus 6 minus what we have here. 3 times 1 is 3. 6 times negative 2 is negative 12. Negative 12 plus 3 give us negative 9. And divide by 9 of x squared plus 2x minus 2. And then minus with 18 over 18 of 3x plus 3. Okay, you can see here you get 3x squared plus 6, and then plus with x squared plus 2x minus 2, and then minus with 3x minus 3. So there you go. W3 equal to 4x squared minus x plus 3. And then done. So B prime will contain W1, W2, W3, which will be x squared plus 2x minus 2, comma with 3x plus 3, comma with 4x squared minus x plus 3. Okay, so that's your B prime. You want to find the B double prime, you can still find the unit vector of each W, and that will give you B double prime. So again, this will be orthogonal basics. All right, so that's how we use Schmidt process to convert any vector, any basics into orthogonal basics or orthonormal basics on that. All right. Now I do want to show you one example where you have everything from scratch. So you can see in the previous two examples, we already got the basics for the system. All right. So the last example for this section is that what happens if you don't have the basics for the system? How would you do it? Then you have to find it. So here we go, right? So suppose you have this system and apply Schmidt's orthonormalization to find the orthonormal basics for the system well. So we have to go all the way to B double prime. But you don't have the basic, so we must find the basic first. So find the base first. Meaning that you're gonna solve the system. So we get 4 variable here. So we get 1, 1, 0, 7, 0, 2, 1, 2, 6, and 0. All right, let's go ahead and solve that. You get 1, 1, 0, 7, 0. You got a 0 here, negative 2 times 1, negative 2 plus 1, you negative 1. Negative 2 times 0 is that, plus 2 will be 2. Negative 2 times 7 is negative 14. Negative 14 plus 6 is negative 8. And then that's a 0 there. And then next leading entry is this guy. So we get 1, 1, 0, 7, 0, 0, 1, negative 2, 8, and 0. And then we can go and get it done. So we get 0, 1, negative 2, 8, and 0. Get a 1 here, get a 0 here, and then negative 1 times that, so we have positive 2 here. Negative 1 times a is negative a, plus 1 is negative 1, and then you get a 0 here. All right, so that's the best we can do, right, using RREF. You can see the rank is equal to 2, and then n equal to 4. So we have 4 minus 2 give us 2 free parameters. Right, so if you write that, you get x1 plus 2x3 minus x4 equal to 0, and then x2 minus 2x3 plus a x4 equal to 0. So we're going to set x3 and x4 to be free. So x3 equal to t, x4 equal to r for some t and r in real numbers. And then we just go back and solve for x1. So therefore, x1 equal to negative 2x3 plus x4, which is negative 2t plus r. and x2 equal to 2x3 minus ax4, which is 2t minus ar. So our solution will be x1, x2, x3, x4, which equal to minus 2t plus r, then 2t plus r minus ar, and then you have t and then r here. And take from this, we can say, okay, so now we have, take out the t, you get -2, 2, 1, 0. Take out the r, you get 1, -8, 0, and 1. All right, so therefore our basics now become -2, 2, 1, and 0, commas, 1, -8, 0, and 1. Okay, so now dimension is 2 of the base is 2. So my W1 in this case will be -2, 2, 1, and 0. And then W2 will be V2 minus, V2 W1, and then W1 W1 times W1, and then you do that procedure again. Okay, so in this case you only have the bases only have 2 vectors, so we only need to find W1 and W2. Okay, so yeah, please go ahead and try. Finish the rest. We need to find B double prime. Okay. Okay, so yeah, so we have 3 examples. The first 2 I gave you the basics, and you just have to use Gram-Schmidt's procedure to kind of find the orthogonal basics, the orthonormal basis. And the last example you just saw here, where they don't give you the base, they just give you the system. So that's easy. You can find the base first, and then use the base to, and then apply Gram-Schmidt's procedure to find the orthonormal basis, orthogonal basis as we needed to. Okay, so yeah, that's the main thing of this section. Is very useful, and we can always do it. So just watch out on the algebra skill, then you should be good. All right.